Okay, next we're going to do our tap drill cycle. So we're going to select our tool, which is going to be a different one. And we're going to select this solid number 16 drill, which if you read the long description is for the 1032 UNC form tap. We're going to keep the default settings. It should be around 3,448 RPM at 13 inches a minute. Feed rate on multi-axis. We're going to select the tool orientation box. We're going to select Z again and our X-axis. And it looks like we need to flip the X-axis again to get it pointed to the right. We go to geometry and we're going to select our 3 holes again. And this time, on our heights, we're again going from model top on both, and we're going to go from hole top to hole bottom, but we want to bust through the bottom with the tip, and we want to go about 5 thread diameters deeper. So we're making a 1032 tap hole. If I take 1 inch divided by 32 gives me a 32nd. And when I go times 5, we're going to go 156 thousandths deeper. So why don't we just round that up to 157. And it's a little confusing. In this breakthrough depth box, you don't have to put a negative symbol. If you put it in the offset box, you do. So we're going to go 157 thousandths plus the tip plus 100. Sorry, we're going to go to the whole bottom plus 157 thousandths plus the drill tip. That way we make sure we got enough clearance for our tap to go in without breaking by hitting the bottom. Our drilling cycle, again, we're going to go to the deep drilling cycle. Our peck depth on this, 0.06 should be fine again. We're in aluminum. We don't need to dwell on the bottom. And we're going to hit OK. Now we're going to go in with our tap. So we're going to drill. We're going to select from our UNC library our 1032 form tap. Okay, we're going to go to the next tab. We're going to pick our tool orientation. Z is in, normal to the plane I just selected, with X to the right, and we flip the X orientation. Go to geometry. We're going to select our 3 holes. And then we're going to go to the heights tab. We're going from model top. Again, we're going from hole top to hole bottom. We're not going to we're not going to select this box because the tap doesn't have, it's a blunt nose on it, so we don't have a drill tip programmed in that's going to go deeper. But we are going to go negative by 4 diameters of the, or 4 thread pitches. That way we make sure we get a fully formed thread. So we'll go back and we'll do our 1 divided by 32, which is our 32 threads per inch, and we're going to go 4 times that to go an extra 1/8 of an inch. And that's going to ensure we have our minimum thread depth. And then in this box, that number does need to be negative to go to the right depth. Okay, we're going to go to the next tab. We're doing a tapping cycle, and we're going to leave all the rest alone. Okay, and there's our threaded holes. All right, now we're ready to move on to the next phase. Let's rotate the machine. So we're looking, going, I guess the rotary would turn clockwise. And we're going to do the features on the side of this part. First, we're going to come in and we're going to do a 2D pocket routine. Okay, we're going to select our 1/4 inch end mill from our UMC library. We're going to take our default settings for feeds and speed. Multi-axis, we want to check tool orientation. We're going to select the face of the part to get Z in the right axis. And then we're going to have our x-axis reference, which would be the front edge here. And it looks like, again, we need to flip the X orientation. We're going to go to geometry. And we're going to select the inside of the slot. You want to make sure your arrow's on the inside of the slot. And then we're going to go to heights. We're going to go from model top on both of these. That's where our start and our rapid's going to start. And our bottom height is going to be selected contours. We're going to go to passes. Our maximum step over is going to be 0.2 for a 1/4 inch end mill. We're going to do multiple depths. Our maximum step down is going to be 0.125 for this. We're going to do one finishing step down in Z. We can leave the 8 thousandths is fine. We're going to use even step downs. We are going to do finish passes. We're going to do wear compensation. Let's put in a smoothing deviation of 4/10. We're going to do one finishing pass, and that step over is going to be 0.01. We'll go ahead and leave lead-ins on all finish passes. Finish feed rate can stay the same. And I think we can safely do a finish only at final depth. We do not want to have stock to leave selected. We're not leaving material for a roughing pass. And we can go ahead and check the smoothing deviation. That should be there as well. Okay, then we're going to go on to the linking tab. We're going to keep the tool down. Horizontal lead-in radius, we'll leave it alone. Sweep angle, we'll leave that alone. We're going to delete the vertical lead-in radius. Our ramp type, we're going to do a straight plunge. We're just doing aluminum, so that should be okay. We have an additional ramp clearance height. Let's set that to 50 thousandths. And let's hit OK and see what we get. Alright, so we've got a couple roughing passes, and then we do a finish pass at the bottom. Alright, there's our pocket. Now we're going to attempt to do this chamfer here. We're going to take our previous chamfer command. We're going to right click on that. And we're going to duplicate it. We're going to take the duplicate and we're going to take it and move it to after the pocket. We're then going to right click on that and edit. And we're going to delete what was already selected. And we're going to back up to the multi-axis tab. We want to select tool orientation. We're going to select the plane we're cutting. We're going to select our x-axis. And we're going to flip that x-axis. Now we're going to go back to the geometry tab. We're going to select the bottom of our chamfer. Make sure the arrow is on the inside. We're going to go to heights. We can leave all of this at default. We're going to go to passes. Wear compensation's fine. I believe we can leave the rest of these alone. Go to linking. Leave all of these alone. Is it okay? And we get our chamfer cut. Now that's going to be taking that all on one pass. It's a lot for it to take off. It is what the cutter's designed to do. Unfortunately, Fusion doesn't have an easy way to do this in steps. So for a larger chamfer on this, it's a fair amount of material to remove. And there is a way we could array it up and do some shifts and then copies to simulate doing a multiple depth cut. Unfortunately, it's not canned and it doesn't just automatically do that. All right, next is the other side. Okay, now we're going to repeat what we just did on the opposite side. So let's rotate our stock so that we can see the side we're working on. And we're going to first duplicate the pocket. Okay, after we've made that pocket, we want to move it down in sequence below the chamfer cut. We're going to go Edit, and we're going to go to the Multi-Axis tab, and we're going to reselect our tool orientation to be normal to the face we're cutting. And we need to make sure our x-axis is pointing to the right, which it currently is for me. If it isn't, you got to manipulate the boxes. I'm going to go to Geometry. Actually, we need to delete all the selections first, then select our pocket. We still have the pocket on the opposite side. We're going to go to Heights. We're going to leave these all at default. Leave these all at default. Leave all the linking tab at default. Hit OK. And it should repeat our cut here on this side of the part. Now we're going to take the chamfer, we're going to duplicate that. Okay, we're going to move the chamfer duplicate to the end. And then we're going to right click on our duplicate, we're going to edit that, going through the same motions. We're changing the face of the orientation. As long as our x-axis is pointing to the right, we're good. Go to Geometry. We're going to clear our selection. We're going to pick the bottom of the chamfer. Make sure our arrow's on the inside. Then we're going to go to Heights. Keep all that at default. Passes, keep all of it default. And linking, leave everything default, and hit OK. There we go. We just got to make sure we're not hitting the floor. So it looks like it's doing just fine. Alright, that is it for the 5-axis routines. Alright, now our last operation is really just to do the back of it in a 3-axis mill. Okay, we're going to do operation 3 now. For operation 3, we're going to go back to our traditional 3-axis mill. So I'm going to hide the 5-axis mill fixture. And we're going to create a new setup. So let's rotate the part in the orientation we want. I personally would put the holes on the right so that we can use a vise stop to pick up or indicate it off the left side as our origin. Okay, so we're going to go right click on setups and we're going to create a new setup. This new setup is we're going to select the part as the body, and our it's not going to be model orientation. We're going to do z-axis plane and x-axis. Okay, we have that set where we want it. And we're going to use a stock box point. Again, it's up to debate, but I would use the lower left corner. Set your tools on a 1, 2, 3 block, put in a stop. That way you can run multiple parts. And we've really, from about here down isn't really milled away, but on our stock, I would like to pick from solid just to make sure that we're getting everything in the orientation we need. From previous may work fine. I'm just a little paranoid about going from 5-axis to another 3-axis setup and not reselecting the body on it. Okay, we're going to go to post-process and we're going to call this program 3013. It's op 3 for VF1. And we're going to use offset number 1. Hit OK. We're going to change the name of our setup to OP3. Alright, here we go. We're going to go to do a face mill. We could really go to our first op and we can do a copy. Go to our second op, do a paste. We're going to right click on that routine. We're going to leave the first tab at default. Multi-axis, we leave it default. Geometry is fine because we already selected that. On our contours, we're going to go from stock top, and then our top height will also start at stock top, and we're going to machine down model top. Then we're going to go to passes. Our pass direction is fine. We could reselect a new edge, but it's really fine. And 0 pass extension's fine. Step over's fine. We are going to select this box this time for multiple depths because we're taking off a lot more material. Now if we remember, we had 80 thousandths to remove. I'm going to do a 30 thousandths maximum step down. We are going to machine from both sides of the part. We'll go ahead and put a finishing step in this time, and our finishing step down is going to be 10 thousandths, and we're going to use even step downs. We're not going to leave any stock to leave, and then we're going to go to our linking tab, and we're going to leave everything here at default and hit OK. Alright, so we get our multiple passes, 30 thousandths at a time, machining off that material. So we get this down flat. Now our next routine is going to be to spot drill these holes. Now let's measure them first. I believe these are 1/4 inch holes. Yes, 1/4 inch diameter. So if we want to put a very small edge break on those, we want to go a little deeper. We're going to do drilling, and we're going to select our chamfer mill. Our 3/8 chamfer mill. And we're going to keep its default speeds and speeds. Multi-axis we'll leave alone. Our geometry tab, we're going to select our holes. On our heights, we're going to go from model top for our rapids. We're going to go from hole top, and our reference for depth is also going to be hole top. And we're going to go a negative. So if we have a 1/4 inch hole and we want to add 10 thousandths per side, we'd add 20 thousandths to that. That gives us 270 thousandths. Divide that by 2, and we need to go 135 thousandths deep, negative. And that should give us a little 10 thousandths edge break at the top of our 1/4 inch hole. Okay, we're going to go on to our cycles. For that, I am going to do a deep drilling, 60,000 steps, and we're going to put a 1 second dwell at the bottom. Okay, our next operation is going to be we're going to go ahead and keep the chamfer mill in the spindle, and we're going to chase around the outside of the part with that. Okay, we're going to do 2D chamfer. I'm going to reselect the tool so it populates our feeds and speeds. Not sure why it gave me that error. And then we're going to go to multi-axis. We're going to leave that alone. We're going to go to geometry. We're going to select the bottom of our chamfer. Make sure the arrow's on the outside of the part. We're going to go to passes. We're going to do wear compensation. We're going to set the chamfer clearance to 0. We're going to check the box for smoothing. We're going to go to the linking tab. We're going to have a horizontal lead-in radius. We're going to have a sweep angle of 0. Where our lead-in distance is going to be 37 thousandths 5/10. We're going to come in perpendicular with a 0 lead-in radius. And if you want to choose the entry position, you would want to probably put it at the beginning of the part and hit OK. Alright, so we've got our chamfer that goes all the way around. And our last routine is to drill the holes. So we're going to go to drilling. We're going to select from our VF1 library our quarter inch drill. We're going to keep the default settings on the feeds and speeds. Multi-axis we'll leave alone. Geometry, we've got our 3 holes. Under heights, we're going to deselect stock, so it goes to the model top. We're going to go from the top of the hole to the bottom of the hole, and our drill tip is going to go through bottom. And on these, we need at the depth that's modeled. There's a little spherical plastic ball bearing we're going to press in there. We're going to go to our drilling cycle. Yeah, we're going to go deep drilling just because this is aluminum. We'll leave the pecking depth at default and hit OK. There we go. We should have everything set to go on here. Alright, so for this project, the deliverable is 3 programs, 3 setup sheets. And 1 and 3 are going to be for the VF1, Op 2 will be for the UMC 750. That's it for this part, and we'll catch you on the next one.